Here, Frosty. Frosty, do you want this? You want that? Here you go. It's a good boy. Here you go. That's a good boy. Good. Nice work, Frosty. Okay, Frosty. Now we're going to talk about another relationship between the Fibonacci and the golden. Now, we know that the golden ratio satisfies this equation. The golden ratio squared is equal to golden ratio plus 1. Yeah, a little bit off the top. Oh yeah, I got that problem. So, I'll just move it down a little bit. How's that? That's good. Okay, now, what we're going to do with that is we're going to change it a little bit, and you'll see why in a minute. We're going to divide both sides by phi, and we're just going to write this in a slightly different way, and that is phi is equal to 1 plus 1 over phi. We just get that by dividing each side by phi. And then that just becomes phi. Phi over phi, that gives 1, and then we get 1 over phi. That's just the same equation, okay? But we happen to know ahead of time that the answer to that equation is a number that's about 1.6. And that's very interesting because 1 over 1.6 is a number that's less than 1. And since phi is equal to 1 over 1 over phi, it's possible to take this phi, this is a little tricky, you may not have seen this before. You can actually take this phi and instead of it, you put in this entire thing. 1 plus 1 over phi. Because this satisfies that. And this is actually also true. This is also a very valid equation. And you can even do it again. 1 plus 1 over 1 plus 1 over 1 plus 1 over phi. After a while, it gets a little bit outrageous. You actually can do an infinite series like this. And when you plug in 1.6, or the number that is 1 plus square root of 5 divided by 2, that's approximately 1.6, into this, and then you calculate backwards this whole thing, you'll get 1.6 again. Now the beautiful thing about this is, if you even just put in a number here like 1, this whole number will become very close to 1.6. Because the effect at this point on the entire fraction is quite small. This one doesn't have to be that exact. So this is a way of approximating phi, or calculating it numerically without having to use a calculator. Oh, well, maybe a calculator, but without using square roots. Back in the old days, people used to do a lot of things like this. So the idea is that you can make a series of expressions. Like you can say 1 plus 1 over 1. 1 plus 1 over 1 plus 1 over 1. 1 plus 1 over 1 plus 1 over 1 plus. Well, the 1 over 1 doesn't really, I might as well just make that 1, right? And then you can see that I probably have room for one more. If I'm lucky. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1. It just keeps going. I almost got that in, not quite. There we go. Okay, now, each of these could be considered to be a rather crude or increasingly accurate approximation to the golden ratio. Like this first one, we know this actually comes out to 2. Well, the golden ratio is about 1.6, so this number is too high. But this is 1 plus 1/2, right? This is equal to 1 plus 1 over 2. That's equal to 3/2. Okay, that's 1.5. That's actually a little bit lower than the golden ratio. Now we look at this next one. This would be, that's 1/2. That's 1 plus a half. That's 3/2. But you turn that over, that's 2/3. This is actually 2/3. Right? That's 1/2. 1 plus 1/2. That's exactly what's up here. That's 3/2, but it's on the bottom. So you have to turn it upside down. You get 2/3. 2/3 plus 1 is actually 5/3. Now the trick about here is this entire expression 5/3 actually shows up right down here. So it's on the bottom. You turn it over, it becomes 3/5. You add 1 to it, which is 5/5. 5/5 plus 3/5 is 8/5. And what you can see here is that this pattern is numbers that get closer and closer to the golden ratio, because this expression gets more and more accurate. It gets closer to the golden ratio. But because the way in which these simple numbers are formed, these are actually the ratio of adjacent Fibonacci's. So the next one here that I know, because I see the pattern, I'll write it over here. The next one is I'm going to take the 8/5, I'm going to turn it upside down to make it 5/8. Then I'm going to add 1 to it, or 8/8. That's going to give me 13/8. Okay? That's the next Fibonacci number. And that's going to be closer and closer. So this tells us that, curiously enough, the ratio of adjacent Fibonacci numbers approaches the golden ratio as those Fibonacci numbers become larger and larger. It gets closer and closer to it. It's really kind of an amazing little thing, but it's not totally mystical, let's say. It turns out that way because of the equation, that simple equation that the golden ratio satisfied to begin with. That ratio, that's the equation right over here. It's this one. But it's the exact same as, this is the exact same equation as phi squared equals 5 plus 1. It's the same. It's from that little equation that you actually get that the ratio of the Fibonacci numbers actually equals that. Okay, great. Thanks. Talk to you later.